It's been almost exactly 3 years since Oracle Team USA won that historic 34th America's Cup win in San Francisco Bay. And here in Bermuda, the scene for the next America's Cup in 2017, the clock is ticking as one of the most important dates in the campaign approaches. The 27th of December marks 150 days to the start of competition here in the Great Sound. But it also marks the first day the 6 teams can launch their one and only America's Cup race boat. The 35th America's Cup is going to be raced on state-of-the-art, high-tech, 50-foot-long foiling multi-hulls. But until their race boat is launched, all 6 teams have built 45-foot development boats to test with. It's on these boats that the technology and the systems to drive it is being shaped. The pressure is on to build the fastest machine.
What you see here is our development program to lead into that boat. So we're limited on how many foils we can make for that boat. Everything you see is the testing and development phase to take that learning to use it for the 50 for our one shot for the Cup boat.
Artemis Racing currently have 2 test boats and a third on its way. Oracle Team USA have 3 and SoftBank Team Japan have 1. Over in the UK, Land Rover BAR have 3 in the water, whilst Emirates Team New Zealand have built and tested their one boat. The French team Groupama Team France have just launched their first test boat. All the team's AC50 race boats will have many elements in common. Much of the specification will be the same.
The boat itself, the AC50, it's pretty much a one design boat. The hulls are the same, the beams are the same, the wing is the same, so all the physical parts, they'll look the same from the outside. What will be different between the teams that we're allowed to work with on design are the shapes of the dagger boards, which, you know, the boat's flying on these foils, and but we're able to change the shape to whatever we want. It's totally open, and how we control them, it's totally open.
And that means it's what you put inside the hulls, it's how you control the wing, it's what you put under the boat, the foils, that's going to give you the vital winning edge. This is why the design and development of the technology is so important. The work on this America's Cup isn't what one may have previously termed naval architecture. This time around, it's all very different. It's more about high-tech systems and data.
I think a control system that most people are familiar with in their day-to-day lives are anti-lock brakes on their car. They hit the brake pedal and the computer keeps them from spinning out or going out of control. And that system that once was just a cable between the brake and the pedal now has another computer there. We're doing that now with the boats. So systems that were once a line you pull, you know, there's a computer now and algorithms that make the performance better, more accurate and precise.
It's a reason why all of the teams have looked outside of the sailing industry for inspiration more than ever before. Cup defenders Team Oracle USA have turned to the automotive and aerospace industries. They're keen to capitalise on a wealth of external expertise.
They will have technology, particularly in those bigger industries, technology that's really well developed, and it's up to us to be able to adapt that technology to our applications.
I'm bringing my expertise in flight control system and in flight control system testing, which are 2 key parameters for the Cup. There is a lot of similarity between this boat and an aircraft. The foil on this boat are exactly as our wing on the aircraft. They allow the boat to go above the water, exactly as the wing allows us to fly. You have to be sure the foil is exactly where you want, when you want. And this is exactly what we are doing on our aircraft with all the elevator, aileron and wing. If you don't have a proper control system, if you don't have an accurate control system, you can't have a stable flight. So you need this control to sail this boat.
One of the keys to controlling the hugely complicated system is through the hydraulics that are powered by the crews as they grind on the winches. For that, the design team need experts in aerospace motion and control technologies.
We control everything that moves on the boat. The jib, the main sheet, the wing, dagger boards, all the pitch control. A lot of it's going to come down to how clever and creative and light and good the control systems gets. And that's going to allow the sailors to be efficient, make the most of their power, which is very limited, and be able to move everything they need exactly when they need it to.
And as all the teams test their 45-foot development boats day after day, this ultimately puts an awful lot of responsibility into the hands of the sailors themselves.
Each position on board the boat kind of has their own somewhat industry they have to learn, you know, so certain position on the boats are involved in the hydraulics, other involved in some mechanical system. And so in that part it's been fascinating because for a lot of the guys, myself included, I mean the America's Cup's always about learning and who can kind of outlearn the other team, but the evolution and just the education process in this campaign has been really one of the most rewarding I can remember.
Are you more of a test pilot now than, you know, than a helmsman?
Well, I think the crews nowadays really are test pilots. The boats are heavily undermanned. They are very, very powerful, yet they are human powered. So it's like you have too much to do during a race, yet you somehow have to prioritise that work list and try and sort of keep your head above water. And that's kind of just doing a few laps on your own. Throw in another boat that's going head to head in a battle out on the water. And it really is about trying to put all those pieces into play. And we essentially have a playbook like a football team. So we have this technical side, a playbook, as well as our racing tactical playbook.
Well, Jimmy, when you're pushing hard in training, it doesn't always go according to plan. There can be the odd sketchy moment, and I've got one right here. What's going on?
This really can happen at any given moment on these boats. You really are pushing the edge, you're redlining. This is an example of going out, came out of a jibe, we just heated up a little bit too much, got a little bit high on the ride height, and ultimately led to a capsize.
Well, all this testing is to produce the 150-foot boat they'll race in the next America's Cup, and that boat is promising to be the fastest race boat ever. If you want more of a rundown, have a look at the sailing pages online. This month on Mainsail, we're looking at the race to build the ultimate sailing machine, the fastest competition boat ever built. 6 teams are all constructing foiling 50-foot multi-hulls that they'll enter in the 35th America's Cup next June. 3 of those teams are based here in Bermuda, where the competition will take place.
As a new team starting up late, we've been very fortunate to be in the position of buying a design package from Oracle. My job really is to work between taking that design package and looking at the requirements specifically of our sailing team. So the ergonomics of our boat are different. We're running our own foil design program, because our guys are looking to sail the boat in a certain way, have certain priorities.
The latest incarnation of America's Cup boats are at the cutting edge of technology, but it's the human interaction with the technology that is paramount.
As a designer, my greatest resource in this team is the sailing team. We have a huge ability to get out in the water and test. In Dean, we've got the best test helmsman in the world.
It's not like motor racing or some of these other sports where you've got a known quantity in the track. We've got so many variables with the conditions, the density of the wind, the water temperature. When you're looking at things which are more performance related, gut feel is very key, but you still want to be able to try and qualify how good that is.
The sailors are constantly giving feedback on the boat's performance and are fully aware of the limitations of both the boat and themselves.
You're always pushing the boundaries of the limits of the equipment. At some point you'd imagine it's going to be pushing the limit of the ability of the sailors to be able to manage the boats, and the rules for us right now, they expressly prohibit the ability for the boat to be flown effectively by computer. So the principle that we still maintain is manual input. As a sailor, you're pushing the boundaries of what you're capable of and really how well that will get the boat around the course.
If the wind is blowing, the teams take every opportunity to test their development boat. The tension is obvious as they prepare to get out on the water, their attitude and posture showing they mean business. Before they dock out, there has to be thorough pre-flight checks. This is advanced stuff. The team are really welcoming. We can spend the entire day with them when they're testing, but there's still some things which we can't film. And at the moment, there's 6 guys under the bonnet of the wing. And remember, the wing is one design, but what's inside it is most definitely not. And currently, for us, that's out of bounds. With every minute of practice time, the boat's performance and its crew are monitored by a flotilla of chase boats. We're following the boat around the Great Sound, and it is sending huge amounts of data to here, to the computers on this boat, which they can then analyse at any time. Oracle Team USA and Artemis Racing are also regularly out on the water here, racing multiple test boats, often against each other. They too are constantly getting digital feedback.
The data that comes off the boat to us here on the performance chase boat is really everything. If you can measure it, we'll be collecting that data, and it runs from simple things like what's the wind doing, how fast is the wind blowing, what angle is the wind blowing. We measure the pressure that the wind creates on the wing. We measure the motion of the boat. We also measure the crew's power output on the winch handles. We measure what the hydraulic systems are, who's pressing which buttons. All of this is being monitored all the time, and sometimes it's as simple as just watching the boat while you see the numbers beside it, because on the boat they've got no chance of seeing anything. They're really just basically reacting to the motions of the boat.
To get a real feel of what the next generation of America's Cup boats will be like, I've been given rare access to go aboard SoftBank Team Japan.
A bit nervous about all this, quite fresh.
It's a real privilege to get the opportunity to see the team test and how the boat performs. Stepping onto one of the fastest boats in the world is pretty awe-inspiring. And within minutes you understand why these boats are compared to Formula One.
We're sailing around the Great Sound here at over 40 miles an hour. It does feel like a test flight. I think back to an Olympic campaign, like the information I could have gathered in a whole 4-year cycle is probably the equivalent of what they're getting off in 1 minute here today.
Dean Barker and wing trimmer Draper are in constant contact with the design team on the chase boat. The efficiency of learning is impressive.
This is developing equipment like the sailing world has never ever seen before. The quantity of information, the pace of learning, the speed of the boat, quite something.
The SoftBank development boat certainly is impressive, but the pressure continues to be relentless in the race to build their AC50. Everybody is aware of the ticking clock. They know that every minute spent out there testing what's going on in this boat is a step closer to having an edge come next year. With these highly complex boats, the lead time from design to construction can be fairly long. So if there's one piece of equipment all the teams could do with, it's a crystal ball.
You know, to launch in January, we need dagger boards in the boat. The dagger boards for that 50 take roughly 3 months to construct. So you're really sort of going, actually we're only 3 or 4 months away from the first AC50 dagger board decision. So what's unique about these boats, I guess, is we have roughly 4 square metres of wetted area in the water when we're up and foiling. Small changes in that 4 square metres can make pretty big differences. You know, I need to try and imagine the board that's going to work with the control system I'm going to have 9 months from now, rather than the one I've got today.
Yeah, we've got one chance to get it right for the next America's Cup. You are making a lot of design choices which you can't undo, and you know, if they're fundamentally wrong, then you know, you've got probably a bit of an issue to try and undo those. So hopefully it behaves exactly as you'd expect it to.
In part 3, we're in the UK, looking at how the British America's Cup team Land Rover BAR are working with their technology partners. But for now, let's take a look at who was making the headlines in Rio 2016. Great Britain emerged as the top sailing nation at the Games, with Giles Scott fulfilling his dream to win gold in the Finn class. Hannah Mills and Saskia Clark also secured a gold medal in the 470, 4 years after winning silver at London 2012. Windsurfer Nick Dempsey came away with a silver, his 3rd Olympic medal. Local sailor Martina Grael and her crew Kahina Kuntz won Brazil's only gold sailing medal in the 49er FX, delighting home fans. In the 49er class, it was a battle between America's Cup sailors Pete Burling and Blair Took and Nathan Outridge and Ian Jensen. They had faced each other at the London Games in 2012, when the Australians came out on top. This time the tables were reversed, and Burling and Took proved why they were the favourites, taking gold with ease. But perhaps one of the biggest sailing victories of the Games was when 54-year-old Santiago Langa won gold in the new NACRA class. He was up against sailors half his age and had recently recovered from having a lung removed due to cancer. A truly remarkable achievement for the Argentinian, who was sailing with Cecilia Carranza Saroli. This month on Mainsail, we're looking at some of the technology that will be used by the 6 teams of the 35th America's Cup as they strive to build the one foiling multi-hull they'll be allowed to race when the action kicks off in Bermuda in 2017. 3 of the teams have based themselves in Bermuda, allowing them to test their designs on the waters that will ultimately host the racing next year. But there are 3 teams that have stayed at home. For British entrant Land Rover BAR, that means here on the south coast of England, nice and close to their technology partners.
We saw huge benefit in being based here in the UK and the partnerships that we have here in engineering and technology, which I think Britain really truly is leading the way. We will get out to Bermuda, I think, early enough to have spent the time on the race course that we need. This team is about the best of British and trying to put forward the best of British in design and engineering, and we believe that will help us win the Cup.
And it wasn't just organisations who the team approached. At a very early stage in the campaign, they quickly made an appointment that reflected the change of pace in sailboat design and construction. They turned to Formula One team boss Martin Whitmarsh.
We need to develop analysis, telemetry, simulation, those techniques, simulator technologies, and those are things that have been developed over the last 20 years in motorsport. So I think the motorsport engineers that have come in, the aerospace engineers, really bring that. They complement the experienced yacht designers that we obviously also have in the team. We're about trying to make quick, iterative steps, and therefore you need very good analysis and simulation tools that have high levels of fidelity and resolution so that you can actually know what you're doing, make the decisions. Because these boats are expensive and complex. You can't make all the bits and test them. You have to rely on analysis and simulation to really refine the products before you get to making them and testing them.
British car manufacturer Land Rover have been at the forefront of vehicle technology and cutting-edge design for over 60 years. With an innovation and development facility a matter of hours from the sailing base in Portsmouth, they were an obvious partner for the British team.
So this is our Virtual Innovation Centre. What this allows us to do is to look at what the customer will see in 3 years' time virtually, so effectively before any data or a machine or prototypes are built.
And this technology is invaluable when it comes to getting hands-on experience in a virtual world, in this case, a 4x4. You might not be able to see what I can see through the camera, but it really feels like I am in a car. I can adjust the mirror, it's just here. All the buttons are here, I can turn the stereo on and off. It really feels like I'm in a car.
What we've been using it for in the boat is looking at how the cockpit is set out in the boat, understanding where the switchgear is and the control systems are, so we can best make them more ergonomically to allow the team to make more decisions more effectively in the boat, so it enables the controls to be reached, etc. So we've used our learning from the vehicle, now carried that back into our boats. We've also utilised that knowledge then to produce prototypes which will be tried on the boat systems down in Portsmouth.
Once the development boats hit the water and are being tested in the real world, it's time for the electronic data that comes back from on board to be analysed. And the detail is staggering.
The America's Cup, at the end of the day, is a design race, it's an engineering race, and data obviously is a big part of that. It allows engineers to make informed choices about what bits and pieces of the boat to work on, what bits and pieces to improve. It allows sailors to validate their intuitive understanding of sailing that particular boat, of how do we push this boat to its limits. Up on the screens here you can see some of the footage from the test boats. And the idea is to show essentially how we are taking the data that's being generated by these boats and feeding that live back to the sailors. And most importantly, we can also see what algorithms are being deployed and how they are learning specific boat behaviors that in the end we can optimize to make the boat go faster. But at the end of the day, this is a race about which sailing team understands their boat better, which sailing team can push their boat to their limits.
And when it comes to sailing's power source, the wind, Land Rover is proving invaluable in its expertise in aerodynamic design.
What you're looking at is the solution of one of our simulations rendered out so you can see the actual car and some of the velocity lines from the fluid file that gets created. Basically, we take the vehicle, whether we're talking about a car or a boat, and immerse it into the fluid, in this case of the boat, not the sea but the air that it's actually travelling through. And then we solve for the velocity and pressure of every single particle in that window of space. We're trying to feed back to the guys on a number of permutations, lots of different scenarios, onset wind conditions, and then how the actual wing sail reacts to those changing aerodynamics. We're able to come back to the guys and make recommendations about how they maybe ought to set up the wing for a number of different conditions. We're hoping that we'll get some significant gains from the boat in this way.
I've found the knowledge involved and the pace of technical refinement for this America's Cup tantalising. And even the engineers are impressed by the machines and their potential.
The foiling itself is a fantastic thing to watch, and an amazing explosion of hydrodynamics that you're actually seeing happening there, lifting these 2.5-ton boats out of the water on something the size of a desktop. It's unbelievable, really.
This Cup, it seems, more than any other, has been presenting design problems that require such a high level of expertise, such a high level of excellence in such very specific applications. Our sport has changed at this level beyond recognition.
I would not have imagined 6 years ago that we're going to be, sailing around and flying boats that, may not touch the water around the whole race course.
There's no question that this edition of the America's Cup is a technology race. It's exploiting the combination of